So I'm about ready to start drilling some holes in the chassis now. I think we're at the point where we can start taking that risk. We got a pretty good idea of where everything's going to be inside the chassis, and I don't think there's a really great risk at this point in screwing up other than accidentally drilling a hole in the wrong place. So one of the first things that has to go in is the tube subboard assembly. And that's going to be attached to the main chassis through holes and threaded holes in the side brackets, and then bolts going into the chassis from outside on the side of the chassis. So I had to figure out where to drill those holes as a starting point. In between episodes, I took a bit of metal off the front there to get around that seam inside the chassis. So I just took a spacer. This is one of the PC boards I had left over from the power supply. I put that there, and then I use that to space it up a little bit to compensate for the thickness of the skin. This is thicker than I need, but that's okay. That gives me a good starting point for the holes, and then if these move down a bit, it's not going to be a problem because it's going to be further away from the meat of the upper L piece. Let's see if you can see that in the shot. So what I'm talking about here is where to drill the hole here in terms of a vertical offset. We don't want to drill it too far up because we start trying to tap into the meat of the upper piece here, which would be hard to do. Rather, we want to be in this section here. So the holes are, I started by drafting a line, tracing it from the bracket against the box, and then taking off the thickness of this aluminum stock, the extruded stock, and then estimating the hole location below that. The brackets will likely sink down a little bit because this is, like I said, thicker than the material inside, but that will only move the holes further away from the top piece, so we should be okay. Once those are drilled, so I'll drill those to M3 size clearance, and then I will put this bracket inside and I'll place it where I want to, and then I'll use those holes to just use the same drill and mark out or spot the locations for the threaded hole. Then I'll drop down to the threaded hole size, drill and tap those. I may go back and use the drill tap that I had previously, which is this here. It seems to work fairly well. You just have to be careful when you're drill tapping, but I may be able to just do this in the drill vise. So the next step, now that we have the holes marked out, I want to get those done first, put this in here, and then have it fixed in place. And then we'll move on to the next step, which would be to mark the locations for the tubes and the clearance holes that go through the top of the chassis. I've just laid out some of the tools I'm going to be using for this operation. I've got a set of metric drills. I have a set of punches. These are actually more than just punches. These are actually sized to go through a hole and to transfer the punch mark against the reference hole down against a surface. So they're what they're called transfer punches. Quite handy when you're trying to match up metalworking. The old method of just drawing a hole, drawing some pencil lead through the hole and trying to center it manually. It can lead to errors. If you just have a set of transfer punches, you can just quite quickly get those holes exactly matched up, as long as the transfer punches are close to the hole that you want. These are imperial, they're not metric, but I've determined that the 1/8 and I think the 5/16 are close enough for me. If I need to, I can wrap a little bit of tape around the 1/8 to get down into the tube socket holes to transfer those. The only real issue at that point is you have to make sure they're straight up and down. They're not offset or kinked to one side or another. Just a standard punch, press punch. These just have a spring in them, and then once you press them down enough, they just pop, and you'll get a hole in the, a mark in the metal to locate your drill. This is a manual type. For deburring, I've got a couple of tools. I use this deburring tool for inside holes, and there's other tips inside of this that you can plug in so you can get the hole from inside as well. So this is for the outside burr. And of course the old manual deburring tool, we'll use that as well. I've punched most of the holes. I'm just going to give you an example of how I set the punch and transfer it. It's easy to get used to. I mean, the difficulty, of course, is getting right on the cross hatch, or right on the X marks the spot in the first place. So I've got the transfer punch ready to go. Just press down firmly on it, and the hole is transferred, or punched as it were. Next step, we got to drill those holes for M3 screws, and then put the sub-assembly back in the box. I'm now setting up my drill press to drill the side holes for the brackets to hold in the tube subplate. So as you see here, I've got a piece of 3/4 inch plywood. I'm just using a clamp here to clamp it to the side of the table, and that way I can rotate it and move it, using it kind of like a radial drill press. The offset allows me to get the box hooked under the side here, so I don't have to worry about it hitting the table itself. And the offset should be, using 3/4 inch plywood gives me a fairly sturdy offhang, so it shouldn't deflect too much when it's drilling. And using this, I can actually fine tune it and get it exactly to the point where I want to drill it. You also notice I'm using a 3/4 inch piece of offcut here to go inside of the chassis here and back up the hole so that the chassis doesn't twist and move around while I'm drilling. It also reduces a little bit of the blowout from drilling. There'll still be a little bit of bits and pieces of metal on the inside from the drilling that have to be removed, and we can just use the tools that we've shown in the previous section of the video to remove that stuff. So without further ado, I'm going to start drilling the holes, and I'll get back when I've got the holes drilled, and then we can see where we go from there. This is a 3mm drill. So I put the tube subassembly board back into the chassis. I've tightened up the brackets. I pushed them away a little bit as I tighten the screws so that it's got a good tight fit. And I'm using this board here just simply as a spacer to set it back a bit from the front so it's not jammed all the way forward. And using the setup, I'll go back to the drill press now and I will spot these holes, and that will put a little dimple in there with a 3mm drill so I can go back and drill it with a smaller drill that I can use for threading. Of course, the board will come back out to do that step. Unfortunately, the board's going to be coming in and out several times, as well as other things as things are fitted and then removed to drill holes for the next phase. So it's going to be a fairly lengthy process. There's nothing really straightforward about it. It's just the way it goes when you're handcrafting something for the first time. There really is no manual process or manufacturing process available. It's a prototype. Just as an additional segment here, just taking a quick shot here to show you one of the benefits of having, if not a floor mount drill stand, at least one that can be put on a pedestal. I have this drill here. It's from a local Canadian manufacturer, similar to something you'd probably get from Harbor Freight. Anyway, there's the drill press there. And you notice that I can move the plate down sufficiently to get the box in here so that I can spot the holes. I don't have to worry about hanging it over the edge or something like that. In this case, I'm not really putting a lot of pressure on it, so I don't really have to worry about supporting it right at the cut. Because I'm just putting a little dimple into the aluminum and then taking it right out again. So I've got the tube sub board now back in. I've tightened down the screws here and here. The board may look a little bit wonky to you, but I checked it with as a machinist square, and if you line it up on the center of the tube holes, they let's see if I can get that in the shot. If you line it up on the tube holes, the center of the tube sockets, you can see they're in line pretty close, and that's what matters. Having the tubes all over the place, higgledy-piggledy on the front, will look a little awkward, but if they're all in line, that'll be good. I think going ahead, I'm going to leave the brackets in, and I'm just going to take the subplate out using the mounting screws here, and that way I can leave the brackets in and minimize the risk of stripping out a thread on them. The only thing I'm going to have to do is loosen the screws up a little bit to get the green tape off the box. Speaking of green tape, you may have noticed that the whole chassis, the whole case is covered in green tape. I do this to prevent accidental scratches. This can happen, for example, when you're on the drill press. If your drill is not completely concentric, if it has a little bit of run out in it, as it's drilling into the chassis will start to rotate a little bit like this with the drill bit. And if there's any material on the plate, that will in turn scratch marks into the bottom of the paint job here. So in addition to making sure that your sacrificial base on the drill press is clean, you can either put a new piece of plywood on there or something else. Also put the tape on the bottom of the chassis to just safeguard against any accidental nicks or other bits of aluminum or metal that would get in here and scratch the surface. And as a final step, you just take the tape off. So I think the next step will be to transfer the center of the tube holes down to the top of the case, and I'll show you what I'm going to be doing for that in the next segment. So I'm ready to transfer the center marks for the tubes down to the top of the plate, and for that purpose I'm going to be using a transfer punch. This is a 1/8 inch transfer punch, and all of the tube sockets have a hole in the center of them. So I'm now ready to transfer the hole from the tube subassembly to the top of the plate to give a clearance hole for the tubes that poke through the top of the chassis. And if you notice, each of the sockets has a central hole in them, and I'm taking advantage of that and using a transfer punch. This is a 1/8 inch, I believe. I've put a little tape around it to tighten up the clearance in the hole so that I get a nice tight fit, and I minimize the amount of off-center that could occur due to the distance between the two plates. So I'm going to now do that and transfer them all across. If you noticed, when I wired it, I made sure that all of the holes were clear of wiring so that as I could easily do this last step without having to do a lot of rewiring in here. Now we're ready to drill these out for the Greenlee punches, and I have a set of Greenlee punches that I picked up here used. This is a 1 inch. I need to go look at my notes and see what I was going to use for the punch size for those, and then we'll get those punched out and test fit the tubes and see how they fit. So I've gone ahead and drilled out I believe it's a 3/8 hole for the Greenlee punches. You need to drill out the holes a bit larger. So I did this in 2 steps, 1/4 inch drill and then 3/8 inch drill. So they're now ready for the Greenlee punches. I'm going to do 7/8 for the 6AQ5 tubes and a 3/4 inch hole, or sorry, a 1 inch hole for the phase inverter, which is 12AU7, I believe, or an AT7. It's just a standard dual triode. And the way I'm going to do this is I'm going to punch. The main boss is going to be on the inside, and the punch itself is going to go in on the outside and punch in. And doing it this way, there's going to be a little bit of deflection as this punch punches in. So there's going to be a little bit of a lip curving into the case. If it was done the other way around, there may be a slight protrusion on the top of the case, which might look a little strange. But punching it this way, I'm hoping that the hole, the way it's finished, will curve in just a tiny bit into the interior of the case. Okay, so I've moved over to my woodworking vise, and I've just got it in here to secure it so that I can worry about working on the punch without having to hold the box at the same time. It's just in there a little bit gently. I don't want to distress or push on the box too much and distort it. So a standard 7/16 open combo wrench will work with these Greenlees, and it gives me lots of leverage, and I can just begin to work on it and drive it through. I put a little bit of lubricating oil on the threads of the punch and also on the outside of the die to help it in getting through the steel. Getting through steel is a bit more difficult than aluminum, so, but the oil really helps to get the process done and get it through with a minimum of strain. It's unfortunate though, I can only get about a quarter turn at a time on the punch, but I think I'm nearly through, and yep, sounds like I am pretty much there. It's just cutting the last final part, and there we go. So we'll take it out of the vise and take a look and see what it looks like. And there's our hole. As you can see, it's very nice and clean. And the edge, as I said, is just curving ever so slightly inwards, which gives you a nice cleaner look to the hole. Versus if you look on the inside here, you can see maybe a little bit of a sharp edge here, because that's the direction that the metal was cut. It was cut inward. So using that technique, and you can see, notice there's no paint chips at all. No paint removed from the chassis. Very hard to do with like a step drill, where you would mess up the paint job and actually create jaggies here. I don't even have to clean this edge up. I can run my finger around it. It doesn't need deburring or anything. It's very nice and clean. I'll deburr the inside of it because it's just a little bit rough, but the outside finish is fantastic. I'm really happy with that. So I'll go ahead and punch the rest of them out, and we'll do a preliminary fit on the tubes and see what it looks like. So that's the last one. I've just finished punching, and what I've done now, extract. I guess the one a little annoying thing about Greenlee's is not much of an annoyance, but you have to completely disassemble it to get the leftover punch, the piece that was punched out, the coin, out of the punch. But I don't mind. These are excellent punches, and it's worth the inconvenience in my mind. They just do an excellent job. Much better than a step drill. So there's our holes. See if I can get it in the shot. We have all our holes punched out. These are the smaller holes for the 6AQ5, the larger hole for the dual triode. Next we can, and as you can see, I haven't touched these. I haven't deburred them or anything. I can run my finger around them. No issues at all. The cut is very smooth, and from the outside it's a very nice curved in, I guess you could say, cut, because the cut was punched from the outside in. The inside is a little rougher, but I don't really care because that's the inside of the chassis. The alignment of the 6AQ5s is pretty good. Unfortunately, the triode is a little bit off center, so that's a bit disappointing. But in terms of the placement of the other ones, it's pretty good. So that's what it's going to look like from the front. All in all, I think it's a pretty decent effort. I think it'll look pretty good when it's all finished. And now on to drilling more holes. And got to get the transformers in now and start looking at the small power transformer and the choke locations on the side of the chassis. And then following that, we need to drill holes for the line input, line output, and the powered audio output. Plus the AC power jack, which I may leave off for a different time. Once I have the wood sidings done, I'll just drill the hole for the power plug at the same time. It's less of an issue with the jacks. I may actually recess those jacks in a bit to otherwise there may be just not enough space on the threads to actually put them in. So now all the holes for the the power supply or the transformer holding bracket, which goes underneath, are all drilled. I needed to punch out 4 holes for the wires that come out of the transformers and go into the main chassis. And for that I used a 5/8 Greenlee punch. Again, outstanding holes on this. I mean, the Greenlees just, you can't beat them. They're better than anything else I know. Just flawless holes punched in there. I don't think I'm even going to need grommets on them because I don't feel any burrs at all on them. Once I clean up the insides, they're just as smooth as butter. So I don't think there'll be any problem with wires getting cut from these holes. So this now mounts on the inside like this, and the transformers go through that. So here's the audio output transformer, and we want this to go in. We want this to go in this way. Here's the output wires. Or sorry, here's the primary and here's the secondary. And we're going to have the, I don't think it really matters which way it goes. I'm probably going to put it in this way because the secondaries can then go out to the output here without having to cross over. And these are put in with 4mm machine screws. And I'll get back once I've got the transformer mounted in there and we can take a look and see what it looks like. So I've got the transformers on now and I've got the tubes back in. I'm just looking at it generally for fit and finish. It looks really nice. You really can't see the wires at all as they're going down into the chassis. Very clean look upstairs. Pretty happy with that. This power transformer does overhang a little bit on the bottom, but you have to remember there's also a 1/4 inch piece of wood that's finished that goes all the way around the side. So I'm kind of hoping that this will line up with the outside of that. I tried to push everything back as much as I could to get it as far away from the tubes as possible so that this has minimal interference with the tubes. There's going to be some, of course, I mean, these are pretty close together, but they're turned 90 degrees to each other to minimize the field effect, so there's minimal field coupling between the two. It's a bit of a duck scenario though, because while it looks all nice and serene on top, things are a bit crazy downstairs. I'm going to have to, despite, I don't want to, but I think I'm going to have to trim a lot of these wires out just because there's not a lot of space in here for routing. So I'll probably trim them to length. It's not really considered to be a good idea, especially for homemade stuff, because you may at some point want to take this apart and improve on it, and you may need some of those leads that you had cut off, although it's unlikely for many of these. An example is like a 16 ohm output or a 4 ohm output instead of the 8 ohm output that you're using here. For this reason, I'll make some exceptions and keep some of the wires their length and then sort of loop them up and tuck them under. But in the case of this transformer, it has a 240 volt input and I don't need that. So I can actually permanently cut that wire off and use some heat shrink tubing to electrically isolate the cut. So the next stage after this will be to look at putting the choke in and the smaller power supply for the front end board, and those will go along the inside, along the sides of the chassis. I'll also do a little bit more exploration on getting the inputs sorted out. I'll have to figure out the arrangement for these and these. This is be the power input on this side, and the speaker output would go somewhere around here, and then the RCA jacks would be on the outside here, here, and here. These also have to be compatible with the outside trim, so I have to make sure that that looks good and works. This is not much of an issue because I think it can just go. I'll put a small recess into the wood, a small mortise to recess this in a bit. These ones I may make the mortise a lot deeper, just so I can recess that outer plastic piece. And these I'll have to think about it whether I want these flush or recessed back in the wood. It really depends on how easy they are to work with if they're recessed. So I've got the preamp board now installed, just fitting it out now. So there's the balance control and the volume. I would have liked the volume to be on this side. I made a minor mistake when I was thinking about the orientation of everything and I got it backwards. But it works. I mean, convention is usually, I believe, volume on this side, but well, for this one it's going to be volume on this side. Anyway, I was checking out clearances inside between the preamp board and the tube carrier board, and I was a little worried about clearances, but anyway, I was saying I tried to get the flashlight or the light to turn on the phone, but I couldn't get it to work. Anyway, I think there's lots of space there. The only thing I would be worried about maybe is there's two higher voltage wires there that carry the plate, that go to the plate of each tube. I may just push them down a little bit or reroute them around so that they don't go near the pots. Yep, that looks pretty good. In terms of where the turrets are below the surface, you can see that there's about 1/8 of an inch of gap between the top of the turret and the bottom of the chassis. There's going to be a metal plate on the bottom of this, so there's plenty of gap there. None of these carry high voltages, so it's not really a huge issue if one of them shorts out. And I can also put some Kapton tape on here or on the bottom of the lid or the bottom of the chassis to insulate them. So that's that section done. The last part of it really is to, well, the next part I guess you could say would be to put the choke on and the low voltage power supply and see what that looks like. So I've worked out some locations for the choke and the low power voltage supply. I'm decided to put the choke on the far side here, and that will go approximately in here like so. And the low voltage power supply will be located around here, not shown, but like so in the chassis. The location of this is far enough away from the power resistor here to prevent it from being unduly heated by that. And the choke over here makes it a little bit further away from the terminals and further away from the choke. If it was located on this side, it would be partially covering the choke, the resistor here, and that would heat the choke up. I want to try and keep components cool, or as cool as they can conceivably be under the circumstances of being in a heated box. So for the holes on this side, I'm just going to use a blank PC board, and I've already marked out the locations, but I'm going to clamp this board here and then use this as a drill guide for the holes, and that way I get the holes exactly right. And using a similar technique on the other side, I can place the choke on the outside of the case and locate the holes and get them accurately drilled. The power supply, the AC switch, the IEC AC adapter, fuse, those will be going on the right side of the chassis. So it's upside down right now, so this is the left side. But when it's flipped up here like so, it will be located roughly here on the chassis. So I'll go ahead and mark out the hole location for that, and I'll start making a great big hole in the back of the chassis for this to fit in. Keep in mind also, like I said before, there's going to be some wood veneer or wood outer paneling surrounding the box, so this is going to be a little bit less than 1/4 inch further out, and it won't actually be flush with the metal surface. That will help to ease some of the clearance issues that might be in here with the ground spade connector. So I'll crack on and get those drilled out, and we can take a look and see what the choke and power supply look like once they're mocked up inside of the case. So I've added 2 bolts to secure the PC board for the last 2 holes, so it will not move around as much, and I'll get much nicer clearance matching with the holes on the PC board. This is kind of a sacrificial PC board. The holes are being enlarged a little bit. I don't really care. It's just an extra PC board that I had, so it's not really a big deal for me to use it in this way. So now I've got the choke and the low voltage power supply mounted in the chassis. I put the tube subplate in for reference and clearance checks, and everything looks okay. Everything's pretty tight in here, but it still all fits. And then with the last really major hole to drill will be the mounting hole for the AC power plug adapter, switch, and fuse subassembly. I'll also go ahead and drill some holes in the chassis for mounting the wooden sides. So they'll be using wood screws drilled from the inside out, and they'll be screwed into the inner side of the outer wooden box. So I've sketched out or measured out the outline for the AC power switch. Just placing the line, the center line, right in the middle of the chassis. There's not really a lot of room, as you can see, with the flange being just about 3 millimeters in width, smaller than the actual chassis. So I pretty much have to put it on the center line of the chassis. Then just taking calipers and measuring the dimensions of this and placing it in on the box using a freehand technique to draw the line. So to demonstrate, what I'll do is I'll figure out where the line is, and then I'll do something like that to draw the straight line. For lines that are 90 degrees to the box, I'll just use a square like this, and I'll just use the edge of the box to get the line. Next steps is to drill 4 holes in the corners, and then using a series of files, or optionally using a nibbler, such as this tool here, I can then proceed to carve out the box. The nibbler is not going to be fun, I can tell you that, because this tool is really hard on the hands when it comes to mild steel work. It's a little bit easier in aluminum. So now I've got the hole made for the AC adapter, or the IEC plug. So there it is, mounted on the chassis. And there's a little bit of looseness in here. It happens that I've never managed to date to get the hole exactly right, so it's a little bit larger than it should be, but that's not really something that I'm worried about. There's going to be a matching hole in the outer wooden skin of the box, and so that's really what you're going to see from the outside. The box got a little scratched up from the files. Again, not really too worried about that. I'm going to have to take some paint off anyway to get some ground straps in to get the box properly grounded to the earth, which is that connector there on the plug. So, I mean, I have to take paint off anyway. What matters really is the outside of the box, and because I kept the tape on throughout the manufacturing process, I don't see at this time any scratches or dings in the paint, so it should turn out pretty good. Final steps are to drill some holes that will be accessible with all of the guts inside of the box, because the last step would be to screw on the outside wooden box and secure it. This has to be done last because of the mechanical screws that are needed to be put in to hold on to everything on the side of the box that has to be done before the wooden sides go on. So I think that wraps it up for this segment. At this point we have all of the holes that we want drilled in the chassis, and it turned out really nice. No real major defects on the paint job. The sides don't really matter that much because they're going to be covered by wood, the wooden box that goes outside. But on the top, I'm really happy with the outcome of this. The hole punch are very, very clean. And I suspect that one of the reasons why the holes look so nice is that the paint job on this is kind of more of a like a plastic style powder coating maybe style of paint job. And when the punch is punched into the chassis, they actually drag the paint in with the punch. So you get a very smooth wraparound. There are some minor defects. If I can close up on that, it looks like a little bit of the powder coating flaked off here. So I will probably just take a black felt pen and just mark that up. And similarly, I can go through all of the inside of the holes and darken them up with a black felt marker to just blend in the the paint job so that there's no bare steel showing on the box. There's a shot of the back with the hole cut out for the power cord, power module, and a shot of the inside of the box, which is, again, like I said, I'm not as worried about the paint job on the inside. The majority of my care and the way I did the whole layout was to try and protect the outside of the box, primarily the front face. So I'm really happy with the way that turned out. So in the next segment of probably the next video, we can start assembling the box. I'm going to probably take a little bit of time to do the wooden box, and I don't know if I'll show that on film. What I want to try and do is wrap this series up and work on just wiring it up, getting everything inside the box and getting it powered up and functional. And as a last step, the outer wooden box will go on to finish up the project. The other thing I have to track down is some rubber feet. So if anybody knows of a good source for rubber feet of the style that you use a machine screw with, let me know in the comments. I usually look at surplus sites for things like this. As an example, I got a pretty good deal on a whole bunch of screws. So here's some 632 lock nuts. I have 440 hardware, 632 hardware. A lot of this stuff I just picked up from surplus places because you can just get large bags of the stuff relatively cheap. And it comes in handy when you're doing a project like this. You don't really have to do any special orders. Just look in your junk bin or your parts drawers and kind of put it together like that. So I hope everybody's doing okay. We reached the November of 2020. Take care. Bye.